I want to introduce you to trigonometry today. It'll be a brief introduction. We'll go into this much more detail next week. Um, so I'm going to just talk about what's called right triangle trigonometry, and that's going to be where we use a triangle to define what the sine, cosine, and tangent are. Now these are all going to be ratios of sides of a triangle. That's the best way to think about it. We'll refine that a little bit next week. But for now, that's why I want you to think about it. And then what I want to do is I want to give you like two brief sort of ways to think about it in terms of stuff in the so-called real world. Okay, so we got to start off with the math. So the sine ratio, sine of an angle, you plug in an angle, and you get back a ratio. And that ratio is going to be the ratio of the opposite side. So the side opposite the angle divided by the hypotenuse. And just to make things sort of simple, we're going to call the height y, just kind of like a y coordinate. And so it's going to be y over h. Okay. One way to remember this is S for sine, O for opposite, h for hypotenuse. Okay. So again, I'm going to define the cosine ratio now, and its definition. Again, you're going to take the cosine of an angle, and you're going to get back a ratio, and it's defined to be whatever the angle is, the adjacent angle. I'm sorry, the adjacent side. Again, over the hypotenuse. And so that's going to be x over h. Okay. And again, cosine, adjacent, hypotenuse, so ka is one way to remember that. And finally, the tangent ratio. And again, I just want to reiterate, this has to be a right triangle. Otherwise, this won't work. So we have a 90-degree angle or pi over 2 radians. So the tangent is going to be, again, you plug in an angle and you get back a ratio. And this ratio is going to be the opposite side over the hypotenuse, over the adjacent side. So opposite side over adjacent side, that's going to be y over x. And it's kind of like a slope. It's kind of like the rise over the run. Okay. And again, tangent, opposite over adjacent. So together you have SOHCAHTOA, and that's what some people use to remember. And I always think, I kind of like to joke, if I ever had a summer math camp, I would call it Camp SOHCAHTOA. And our motto, I guess, our insignia would be a triangle. Anyway, okay, so that's the beginning. So in the way that you find these, you figure out what the angle is, and you just go to a calculator, and you'll see stuff like sine, cosine, or tangent on it, and you'll plug in the angle. Now, most calculators can be either degrees or radians. However, the default is radians. And usually you get to choose the mode, and we'll go through all this in class on Thursday. Okay, so we're going to see these things for the rest of the semester, maybe defined a little bit differently or different context, but whenever you think of the sine, cosine, or tangent, you can think of it in terms of a triangle. Okay, so I want to do two examples, and I'm going to remind you of two ratios. We have the angle y and the hypotenuse, and we're going to use this one at one point, the tangent y over x. The tangent of theta is going to be defined to be the ratio of y over x. And then we're also going to use, at another occasion, we're going to want to use this ratio, and we're going to be given h, and we have to find y. So we're going to want to use this ratio, y over h. Okay. Okay, so here's example number one. You want to, there's a tree, and for whatever reason, you want to cut it down. Maybe it's a Christmas tree. Maybe you're going to use it for firewood. You're standing right over here. Here's the ground, right there. And you're going to make an angle. You can measure to the top of the tree. And what you want to find is this height. So you want to find the height, which is y. And you can measure the distance between you and the tree. Let's say it's 100 feet. Okay. So again, you can figure out the angle between the top of the tree and where you're standing. There's various ways to do that. Maybe using a surveying instrument or something like that. And then we want to figure out what the top, we want to figure out how high the tree is. So we're thinking of the tip of the tree to the ground as the height y, and we notice that the distance along the ground is x. So we're going to, we know what x is, we know what the angle is. Let's just say it's 45 degrees, and we know what y is. So we can say, okay, well, I'm using an angle between the opposite side and the adjacent side. So that's OA. And so I say, okay, well, what's the tangent ratio? So I'm going to use tangent is equal to the opposite over adjacent, which is y over x. We know what the angle is, so let's see what we know. We'll plug in. We have the tangent of 45 degrees. And if you remember from the last video, 45 degrees is the same as pi over 4, and that's equal to y, but we know what x is. X is 100. So we have an equation we can solve there. All we need to know is the tangent ratio, so I go to a calculator, I plug that in. I get 1 is equal to y over 100. Multiply both sides by 100. I get the height of the tree is 100. Okay, so that's an example of trigonometry, and this is this is a way that it can be used. You can measure the height of something from the ground. You just need to figure out what that angle is, and again, there's tools that allow you to do that. Okay, so that's my first example. So I want to give you another example where we're going to find we want to find the height, but we're going to do it slightly different way. I'm going to imagine that this is the profile of a hill. It's man-made. Okay. And there's going to be something up here. There's going to be a house up here. Okay, so that's and it's actually going to be better than that. And I want to know how high is the house from the ground, from the starting level, let's say. So this is going to be the starting level, the starting height. You're going to be down here. You know that that angle is equal to 30 degrees, or pi over 6 radians. Again, we saw in the last class that 30 degrees and pi over 6 are the same. Now you walk up here and you measure that this is 200 feet. And you want to know how high this is. So what's y? Look at my ratio. I know the opposite and I know the hypotenuse. So that's OA. So I go back, well, right here. The sine is going to be opposite over hypotenuse. So I know that. So I figure that out. Okay, so the sine of pi over 6 radians is, we know the ratio is equal to the y ratio over the hypotenuse. We don't know what y is, but we know what 200 is. So that's my equation. Now I go to a calculator and I plug in pi over 6 radians, and I see that this is equal to 1/2, and that's equal to y over 200. So to solve for y, multiply both sides by 200, and I get 200 over 2 is equal to y. Sorry for the shadow. Let me move it out of the shadow so you can see it. So that's going to be equal to 100. Okay. So again, I just wanted to give you a flavor for this stuff. I wanted to say what these ratios were. and I wanted to give you two examples. Here, we know we can measure on the ground, but we can't measure the height. It's just too hard. But we can figure, if we can figure out this angle, we can set up the tangent ratio, figure out what the height is. For this one here, it's a little bit different. We have a hill here. We can't walk through the hill, so we can't measure this distance, but we can walk up the hill. And we can measure this distance as 200. We want to know how high y is above where I started. Well, again, I'm going to be using the ratio of opposite over hypotenuse as I did here, so the sine ratio, and I work through this. So just quick review, and this will be it. Basic right triangle, the sine is going to be opposite over hypotenuse, so y over h. The cosine is going to be adjacent over hypotenuse, so x over h. And the tangent is going to be one side over there, the ratio of the sides, so opposite over adjacent. Okay, hopefully that's helpful. We'll go into this in a lot more detail next week. Thank you.